Hi guys, welcome to lesson 5-6, parallel and perpendicular lines. Our objectives for today are that I can determine whether lines are parallel, perpendicular, or neither, and that I can write equations of parallel and perpendicular lines. New vocabulary for today: parallel lines are going to be non-vertical lines that have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. Perpendicular lines are two non-vertical lines are perpendicular if the products of their slope is -1. A vertical line and a horizontal line are perpendicular. So in order to find the product of their slopes being -1, they're going to be opposite reciprocals. So you would have m and you would have -1 over m. All right, so if you multiplied those two together, your answer would be -1. Our essential understanding is that you can determine the relationship by two lines by comparing their slopes and y-intercepts. So let's start by writing an equation for a parallel line. We have a line passing through the point -3, -1, and we are told it is parallel to the slope of y equals 2x plus 3. We want to write the line in slope-intercept form. Well, as we learned in our lesson on point-slope form, we can write an equation and then just convert it. So, first thing I need to do is identify what is the slope of the line, because two parallel lines have the same slope. So my slope is right here. So the slope for this equation is 2. So I'm going to have a slope of 2, and it's going to go through the point -3, -1. So if I start off by writing my equation in point-slope form, y minus -1 is equal to 2 times the quantity, x minus -3. Now my first step is to take care of those double negatives, and I'm going to do that by just making them addition. So we have y plus 1 is equal to 2 times the quantity, x plus 3. Our next step for solving this, or getting this because we wanted it in slope-intercept form, my next step is going to be to distribute the 2 times x and 2 times 3. So we have y plus 1 is equal to 2x plus 6. My last step is going to be to subtract 1 from both sides. Y is equal to 2x plus 5. So that is an equation that goes through the point -3, -1 that is parallel to y equals 2x plus 3. All right, so letter B, we're going to write an equation in slope-intercept form that passes through the point 215 and is parallel to the graph of y equals 4x minus 1. So 4 is my slope, 2 and 15 are my points, so my equation is y minus 15 is equal to 4 times the quantity, x minus 2. Start by distributing. Y minus 15 is equal to 4x minus 8. And now we need to add 15 to both sides of my equation. And y is equal to 4x plus 7. All right, so we have an equation that is in slope-intercept form that is parallel to y equals 4x minus 1. Notice 4x and 4x are the same, we just have different y-intercepts. Okay? Why don't you guys go ahead and try letters try letter A. So we want to write an equation in any form for a line that passes through 1023, great date, and is parallel to the graph of y minus 5 is equal to 7 times x plus 4. All right, so we have a point, 1023. We have a slope, which in point slope form is right outside that parentheses, so our slope is 7. All right, so now we need to write this, and it says any form. So the easiest form that we can do is point slope form. So we have y minus 23 is equal to 7 times the quantity x minus 10. And since it said any form, we can just leave it like that. We don't have to do anything else. No need to convert it to slope-intercept. Okay, so in these kind of questions, especially on our test when you take it, you want to be very careful that you are reading what the directions in the problem are telling you. And in this case, it was write an equation in any form. So point slope form would be acceptable. All right, problem number 2 is all about classifying lines. Now, we want to identify, are the graphs of the equations parallel, perpendicular, or neither? So in order for us to figure this out, we need to know what is the slope of each of our equations. Now, the first equation, y equals 3/4 x plus 7, is already in slope-intercept form, and we can already find the slope, and it's right there, it's 3/4. Now, the second equation is in standard form, which we learned about yesterday. Standard form does not let us see the slope very easily, so we need to solve that equation for y. Let's put it into slope-intercept. So we're going to start by subtracting 4x from both sides. We have negative 3y is equal to negative 4x plus 9. Now, some of you might be wondering, I know I've gotten the question before, why did I put the negative 4x first before the positive 9 when we're subtracting? And the reason for that is our general conventions for writing equations, we start with the variable that has the highest exponent, or the term with the highest exponent. We have x to the first power, and in here we could, technically there's an x to the 0 power. So we don't need to worry about that right now, but just know you put your x term first and then your constants. And if when we get to equations with things that are being squared or cubed, those would go out in front of the x. The highest exponent is first. All right, our next step, because we're not in slope-intercept form yet, is to divide both sides of the equation by negative 3. So y is going to be equal to negative 4x over negative 3 minus 3. So those two negatives are going to cancel out, and we've got y equals 4/3 x minus 3. Now, before at the beginning, when I defined parallel lines, we said they were the same slope. Well, I've got 3/4 and I've got 4/3. Not the same slope. Okay? Perpendicular lines were if we can multiply them together and they equal -1. Well, are these opposite reciprocals? Well, 3/4 times 4/3 is just going to equal +1. They are reciprocals, but they are not opposite reciprocals. So these lines are neither. Okay, they are neither parallel nor perpendicular. They're just two lines that are going to intersect. All right, letter B, we have one equation. Our second equation is already in slope-intercept form, so we have a slope of 2/3. And our first equation is not, but it's really close. So let's just divide both sides of our equation by 2, and y is going to be equal to negative 3/2 x plus 6. So we have a negative 3/2 x and a positive 2/3 x. So let's try multiplying those two. Negative 3/2 times 2/3. 6 over 6 is 1, and it's negative. So these are perpendicular. Now, you may see some conventions or some shorthands for parallel and perpendicular. So parallel lines are just two kind of diagonal lines-ish. perpendicular line, perpendicular can be represented as two perpendicular lines, so like an upside down T. All right, I want you guys to try letters A and B, and then we're going to go over them. So my first step, I have neither equation is in slope-intercept form, but I can get both of them there. So the first thing I'm going to do in our first equation is distribute 4 times x and 4 times 3. So y minus 7 equals 4x plus 12. Okay, now I'm going to add 7 to both sides of my equation. And I get y is equal to 4x plus 19. All right. Y minus 4x equals 19, so we can add 4x to both sides. And we are left with y is equal to 4x plus 19. So if we look at our slopes are the same. Our y-intercepts are the same. So these two equations are the same line. So I would not say that they're parallel. They are the same line. I guess technically you could kind of sort of maybe say they're parallel, but because a parallel line would have to have different y-intercepts, and they don't. They have the same y-intercept. So it is neither because they are the same line. All right, let's take a look at letter B of the U-tries. So we need to get both of these into slope-intercept form so that we can compare. So the first equation, I'm going to subtract 6x from both sides of my equation. So 2y is equal to negative 6x plus 14. Divide both sides by 2. And y is equal to negative 3x plus 7. So one equation down. Now let's take care of the other one. First step is to distribute the negative 3 times x and negative 1. So I have y minus 7 equals negative 3x plus 3. My next step is to add 7 to both sides of my equation. And y is equal to negative 3x plus 10. So taking a look at these, we have the same slope, negative 3 and negative 3. And we have different y-intercepts, positive 7 and positive 10. So these are parallel. They are parallel lines. All right. So problem number 3 is possibly where you guys are going to get tripped up the most, and it's writing the equation of a perpendicular line. Now, perpendicular lines, remember I said we have the opposite reciprocal for the slope, and we need to start there. So first thing we need to do is figure out what is my opposite reciprocal of my slope. Well, my slope for the equation is 2 because the equation is 2x plus 1. So the opposite of 2 is negative 2, and the reciprocal is negative 1/2. So my slope is going to be equal to negative 1/2. Now we want it to go through the point 1,8, and that we want it in slope-intercept form. So I have a point, I have a slope, I'm going to use point-slope form to write this equation. So we have y minus 8 is equal to negative 1/2 times x minus 1. Okay, my first step is going to be to distribute. So we've got y minus 8 is equal to negative 1/2 x minus plus 1/2. Then we're going to add 8 to both sides of our equation. And you've got y is equal to negative 1/2 x plus 8.5. All right. So our slopes, 2 times negative 1/2 would be negative 1 when we multiply them. All right, so these are perpendicular. Letter B. We're going to start with, we have a line passing through the point 10, 15, and we have a slope of negative 5/6. So the first thing we do is find what our new slope is going to be. So our new slope is going to have we're going to take the opposite of negative 5/6, so it'll be a positive 5/6, and we need to take the reciprocal, so it'll be 6 over 5. All right, so now I can write my equation, and I want it to be in slope-intercept form. So I'm going to use point slope again and solve my way there. So we have y minus 15 is equal to 6/5 times the quantity x minus 10. So first step is going to be to distribute. Y minus 15 is equal to 6/5 x minus 12. My last step is going to be to add 15 to both sides. So y is equal to 6/5 x plus 3. Okay, so there we are, slope-intercept form, and it is perpendicular. Negative 5/6, positive 6/5. So opposite reciprocals. All right, you guys try letters A and B, and then we will go over them. All right, a line passing through the point 2, 3, and is perpendicular to the graph of y equals negative 3x plus 4, or negative 3x minus 4. What equation represents the line in slope-intercept form? So my slope is the opposite reciprocal of negative 3, so my slope is going to be a positive 1/3. And I'm going to use point slope form. Y minus 3 is equal to 1/3 times x minus 2. First step is going to be to distribute. Y minus 3 is going to be equal to 1/3 x minus 2/3. Add 3 to both sides. Y is going to be equal to 1/3 x minus 2 1/3. If you want to write those as a mixed fraction, you can. It's up to you. All right. Letter B. A line passing through the point negative 4, 6, and is perpendicular to the graph of y equals 2/3 x plus 5. Opposite reciprocal of 2/3 is going to be negative 3 over 2. So y minus 6 is equal to negative 3 over 2 times x minus negative 4. Minus negative 4, we can change that to addition right away. All right. Our first step is going to be to distribute the negative 3/2 times x and 4. So we have y minus 6 equals negative 3/2 x minus 4 times 3 is 12, divided by 2 is 6. Okay. Next up, our last step, we need to add this 6 from the left to the right, and we're going to get y is equal to negative 3/2 x. And that is in slope-intercept form. It just has a y-intercept of 0. Okay. That is it for today's lesson, guys. Make sure you guys rate your level of understanding 1 to 4. Write down any questions you may come up with. My guess is, if you have any, they may be surrounding the idea of the opposite reciprocal. And make sure you write a summary. How can you find that lines are parallel or perpendicular, and how can we write those equations. All right, see you in class. Have a great night.